Okay, so we had to skip a little bit of that. Let me take a look at this function here. So we've got that graphed. We're going to check our answer. One thing you'd want to be careful is you want to plug it in correctly. Do you need parentheses on this? Yep. Absolutely. Around the entire top, so that's going to be 2x squared minus 6x. And then divide around the entire bottom, so that's going to be x squared plus 2x minus 8, close the parentheses. Now, when you have your calculator do these, you want to plug in the original one, even if it's simplified. Go back to the original one if you were going to check this, okay? This window needs to be fairly big. We've got to go to about -5 here. So I'm going to do this. I'm going to hit zoom 4. I'm going to hit the decimal window. Okay. And in fact, this is so high up we can't really see it. So I'm going to zoom out. So the calculator has all these pixels on there. I mean, it's pretty dumb. It's literally doing an XY table. Okay, it's plugging in X's, plotting that point, and then connecting the dots. So it looks like this doesn't go up here. I'm going to hit zoom 6. Now, if you've got a newer calculator, so this is -10 to 10. Okay, what is this? Is it drawing the asymptote for you? Shane, what do you think? Is it drawing the vertical asymptote? Okay. Of course would be the incorrect answer. Okay, what it's doing is it found a point up here, it found a point down there the next time, and so it just connected the dots. All right, same thing here. The last point, the last pixel that it plugged in, it found a point right here, then one right here, so it connects those. Okay, if you've got an 84 silver or something like that, it may not do that. Okay, they kind of improved it. Okay, but here's what I'd like to do. Does our graph look right? No? You don't think our graph looks right? Okay, yeah, this one looks good. Does this look like a pretty good approximation? We can double check our work. I'm going to hit trace. Look, it goes through 0, 0. Let's hit 3. It goes through 3, 0. The other point that we've got on our graph is 1, 4/5, so that should be 0.8. So did we get it right? Absolutely. Okay. Now, we've only done, let's see, 1, 2, 3. We've only done 3 of those graphs. And we've already got something figured out that would scare most people. Okay. Any questions? Again, if you're going to use your calculator to check, I don't mind. You should get this all first by hand, and then just make sure you plug it in the calculator correctly with those parentheses. Yeah?
I do have a question. Why did it stop on the calculator?
What do you mean?
Because you have the arrows pointing, so that means it continues.
Why did it stop right here?
Yeah.
Because it literally just it found a pixel. So watch. If I hit trace and I go like this, okay, watch. See that one right there?
Okay.
That's at 2.1. See that one right there? It's at 1.9. So it goes up to 8, and then the very next pixel it picks, it's at -4.
Okay. Is that
So
because of the vertical line test? Or?
no, that's just because of the pixels on the calculator. Okay, if I hit zoom 4 and go back to the decimal window, doesn't stop there. In fact, I can change the window, and let's go from -10 to 10. Yeah, it still does the pixels, I guess. Any questions? Okay. All right. Let's see. Let's look at that one. Okay, so we're going to do this one. And this is enough information that you can finish 4-3, and you can do most, if not all, of 4-4. First thing we do, very easy question. Is it proper or is it improper? Improper. So this one is improper. Good or bad? Improper. It's the good type. So that means it's y equals, leading coefficient of the top is 3, leading coefficient on the bottom is 1, so the answer for the horizontal asymptote, 3. There's our horizontal asymptote. Next piece of information. Notice we've got a little less space here because we're probably getting more efficient at it. That, and I care about the trees, of course, because they have feelings too. Okay. Next thing we do.
Very sick class today.
Okay. So we're going to factor this and we're going to figure out, hey, do we have any domain issues here? So if I take out a 3x, I'm left with x minus 1. On the bottom, I need to factor that. So I need numbers that multiply to be negative 12 combined to be positive 1. So that's going to be plus 4 and negative 3, right? Any questions there? What can't we plug in? Negative 4 and positive 3. Do either of them cancel? Nope. So those are both vertical asymptotes. Next. Intercepts. So we're going to plug in a 0 for x. That'll find the y-intercept. If we do that, the easiest place to find the y-intercept again is back at the original one. If you plug in a 0, what do you get on the top? A 0. What do you get on the bottom? A negative 12. So 0 over negative 12 is 0. So that's going to be an x and a y-intercept. I'm now going to plug in a 0 for the y. So I'm going to come back up here and I'm going to put a 0 right here. And what part of this do I get to ignore? The denominator. I don't even need to worry about that. So what's the x-intercept that comes from here? X equals 0 and x equals 1. We've already got the 0, so we know it crosses at 1. Okay. Anything else we need to do before we start graphing? Nope. That's pretty easy. Proper or improper. Simplify it. Figure out where the domain issues are. Figure out whether or not they cancel. That'll tell you whether you have holes or vertical asymptotes. And then just find the x and y intercept. That's enough to get started. So I'm going to come back here. We've got a horizontal asymptote at y equals 3. Y equals 3. Whoops. Horizontal asymptote. Negative 4. Vertical asymptote here. Positive 3. Vertical asymptote here. And I've got 2 points on the graph. 0, 0, and 1, 0. How many branches? How many? 3. How many of them are easy to find? 2. Okay. The fact that there are no x-intercepts here and that the horizontal asymptote is 3, positive 3, means it's got to run along this horizontal asymptote and then go up or down. Which does it have to be? It's got to go up. Over here, same thing. It's got to run along here, and its only choice is to go up because there are no x-intercepts over here. Now, a little more tricky here. See if you can picture what it would have to look like. There are only 2 options. Come here. What's the multiplicity of each of those zeros? 1, so touch or cross? Cross on both of them. So it's either got to do something like this or like this. How do we figure out what it is? I don't think you could say that. Yeah, plug something in. What do you want to plug in? Okay, I would say plugging a number in over here would be fine, or plug in positive 2. We're going to plug in negative 1. So if we plug in a negative 1, let's see what we get. I get 3 times negative 1 times negative 2 over, let's see, if I plug in a negative 1, that's going to be a 3, and that's going to be a negative 4. Is that all right? So I've got a positive 6 on the top and a negative 12 on the bottom, so it's negative 1/2. So right here, it's negative 1 comma negative 1/2. So if I get from here to here and I cross through, there, got to go down here, got to go down here. Any questions? Yeah. These up here? What we did is we said, look, it's got to run along this horizontal asymptote out near the ends. So out near the ends, it's got to run along like this, and then it's got a choice, either to go up or to go down. And we ruled out going down because if it had gone down, it would have to cross through the x-axis. So this piece has got to go up, and this one's got to go up for the same reason. There's no x-intercept over here. Okay? So having the good type of improper really makes the graph a heck of a lot easier to find. Okay, any questions? Okay, here's what we've got left. Just these problems right here. There are 4 of them. What would you do on this one? What's the first thing we do? Proper or improper? Okay, now what's wrong with this? Yeah, we'd normally write it like this. So we're going to write negative 2x minus 4 over x plus 1. Okay, think of it that way, and then we're going to say this is improper, but the good type, and we get y equals negative 2. There is our horizontal asymptote. Next up, factor, right? So this would be a negative 2, x plus 2, x plus 1. What's the problem in the domain? Negative 1. Does it cancel? Nope. So what is it? Vertical asymptote. So that quickly we've identified the horizontal asymptote and the vertical asymptote. Next, intercepts. We'll make a little xy table. We'll plug in a 0 for x. If you plug in a 0 for x, either in the original one or the simplified one, it doesn't make any difference. If you plug in a 0, you get a negative 4 on that. Whoops. You get a negative 4 on the top, and you get a 1 on the bottom. Is that right? Did I do my arithmetic correct, Alex? So this is going to be a negative 4. Then you plug in a 0 for the x, or excuse me, for the y. So we're going to set this equal to 0. What's the only part of this I need to be concerned with? Just the top. What's the 0? Negative 2. Let's keep this in mind. The book never asked for this, and it doesn't even point this out. What's its multiplicity? 1. Touch or cross? So at negative 2, it's going to cross there. So let's start plotting these points, or these asymptotes and everything. Negative 2. Horizontal asymptote. Negative 1. Label it up here. X equal negative 1. Vertical asymptote. And some points on the graph. Negative 4, 0. Right there. Or sorry, it's right here. Negative 2, 0. And 0, negative 4. Okay. Is this one where you have to pick some points to figure out what it looks like? How many branches? How many pieces? Just 2. Okay, if it runs along here and it has to hit this and cross through it, it's got to look like this. Oops. Can it cross back down and end up pointing downward? Nope. Got to go like that. If it runs along here, crosses the y-axis here, is there any way it could turn around and go up? Nope, because there's no x-intercept, so that's what it looks like. Okay? Yeah.
How'd you get the negative 2 in the second?
This one? Set this equal to 0. So you're solving negative 2, x plus 2 equals 0. Whoops.
Oh.
You're just finding the x-intercept, the roots, the zeros, okay? All right. Let's see, today's Wednesday. Didn't we map out the whole rest of the week for this one?
Yeah.
I think we did. So tomorrow we're going to finish it up. Don't be surprised if Friday we have a quiz. What would be great is if you know everything 4.1 through 4.4 when you walk out of here on Wednesday. The exam is a week from tomorrow. It's on the 16th, okay? All right. Have a great day.